Portland is considered one of the most sustainable cities in the country. We are perfectly nestled between Mount Hood and our Great Coast. So we pretty much have it all for hiking, biking, any sort of outdoor activities.
Portland was the first city in the United States to set a goal for reducing carbon emissions. That was in the early 90s. People come to Portland from all over the world. They want to know how Portland did it.
We're also one of the few cities outside of California that has actually reduced the per capita motor vehicle carbon emissions.
Some of the unique challenges that we have here are rain events, our diverse landscape. This includes some of our steep roadway cross slopes and running slopes.
The city of Portland, like every agency, has a limited amount of resources. We strive to design things in a way that is efficient and buildable and constructible. There's a direct relationship between how efficient we are, how much time we spend on a project, and how much we can actually build.
That's why it's so important for us to have the right tool for the job, to get it done efficiently and sustainably as we're building the most sustainable city in America.
The 3D model allows the contractor and the surveyor, and sometimes even the public, to see what we are building before we're building it. This new feature, geospatial context, came out. We developed some code that allowed us to use geospatial context and all of our data, and with a click of a button, in about 10 seconds, you bring in all of your GIS background files. For every project, 8 hours turned into 10 seconds using Bentley products. It was a huge win for the city, a huge win for our CAD team. It is a huge time save.
So good afternoon and welcome everyone to the city's panel of YII Infrastructure 2025 conference here in Amsterdam. You've just seen how Portland in the US is leading the way in efficient and sustainable urban development, leveraging smart tools, geospatial data, and efficient procedures to reduce carbon emissions and build resilient infrastructure. It's a powerful example of what's possible when cities embrace innovation and go digital. And I'm excited today to explore this approach further with our Experienced Cities panel. A representative of a European capital, an engineering firm, an academic expert, and an industrial facilities specialist. Together, we'll dive into how connected cities and connected technologies and cross-sector collaboration are shaping the future of urban infrastructure. So let's get started. And please welcome with me Rebecca Herrera Rodriguez, Head of Building Permit Innovation at the City of Madrid. James Moore, Global Technical Director for Places at Hatch. Professor Andreas Jurilionis, Dean of the Faculty of Civil Engineering and Architecture at Kaunas University of Technology. And last but not least, Yuan Lei, Chief Engineer of China Baowu Engineering and Technology Group. Thank you so much for being with us today. And Rebecca, I'd like to start with my first question to you. Obviously, Madrid is undergoing a major digital transformation. Could you share with us which aspects of construction and urban infrastructure are considered, and what part of this effort is leading to that infrastructure, better connectivity, as we said here?
Well, thank you, Richard, Dorothea, and all the Bentley team for inviting me to this incredible event. It's an honor for me to be representing Madrid here in this conference. And regarding your question, yes, Madrid is living a major digital transformation that we call Madrid Capital Digital. It began 2 years ago in 2023, and it focuses on improving public digital services across all the city departments, but also the city districts. And for example, about this construction and urban infrastructure changes, we are aiming to go for a more resilient, sustainable city with projects like, for example, changing and converting a highway that separates two different districts to a green corridor, using for the first time in our city BEAM methodology from the beginning of the project and now in the construction phase. That is a massive step for this digitalization. And another projects like Madrid VP, Digital Building Permit. This is the project I'm working on. And just to put you in context, now in Spain and in Madrid, to get a building license, you can take from 6 months to a year, even more. But with Madrid DVP, we are going to automate this process with a digital platform. So everyone, like users, can upload their BIM models in an IFC format, and they can pre-validate it to the, or against the urban planning rules that are already into a machine language, readable language. So obviously, this is going to get better in times of like maybe just getting like 2-3 weeks to get the building permit, but also it changed the way that everyone can work on it, because for the first time, architects and real developers are going to be able to check from the beginning of their projects if it's complied or not, and don't wait until the last part of the design to know if they are right or not.
Yeah, you spoke a little bit about it. We hear a lot at this conference about connectivity. So how do you now, with this transformation going on, how do you support that information sharing across disciplines, across departments in your city?
So for example, in Madrid DVP, we are using open data for our project, but I think the most important thing is about to understand that these kind of digital projects, we need to get involved different expertise areas, such as urban planning, IT, digital, legal, but also to understand the stakeholder needs and to listen to the technological providers as you, to know what are the different options to get the better solution for it.
Yeah, sounds very ambitious. And are you considering an urban digital twin as a tool in this context?
Yes, actually we have a digital office that is working on a digital twin, and we consider it as a key element of our digital transformation strategy. Actually, for example, this digital twin is the core of one project that we call Sueña Madrid in Spanish, or Dream Madrid in English. That is our new urban planning, like the general one for the whole city. It's the first time that it's going to be fully digital. So this is kind of incredible. And instead of having like a static document, we are building a city simulator to have live database picture of Madrid, so we can adapt this urban planning as the city is moving forward. And about this digital twin, it's going to have data from different sources like BIM, GIS, but also dynamic data from mobility ecosystem or energy systems, where interoperability is the key for success. So, I mean, we really need it. And for example, with this city simulator, we are going to be able to have different projects, like, for example, like in Madrid during summer, we have lots of heat waves. So we can take where the heat waves are going to impact, and then make decisions previously. So I think it's going to work really, really well. So the idea is to have this digital twin, to have a real picture of Madrid every time we need to make a really big decision.
Well, sounds more like a dream even, right? It's coming to reality.
Yeah, but the projects are now on, so yeah, definitely.
Perfect. Coming to you, James, you are leading at Hatch, a big engineering company, the global business for cities. How do you describe the advantages of an urban digital twin to your customers?
Good question. Typically, we have a lot of public sector customers, municipalities and communities. We also have some private customers. Public sector customers, by definition, have to worry about the public, so it's a very broad remit. Private customers are often very much focused on a specific metric, say a return on investment, financial, et cetera. So there's a distinction between the customer types. But public sector customers typically understand what we're trying to do. I remember a long time ago, I'm old, when I started, you would go around and you'd go to all the different departments, you know, the land use, the planning, zoning, water, utilities. Somebody would take a set of drawings off a shelf and they'd make you a copy and you'd bring them all back. And they were done by different people at different times, often using different systems. And our job was to try to figure out how to integrate all of that. And it was very time-consuming, literally trace paper and pencil sometimes. And regardless of what you did, at the end of your project, that went on a shelf and that was all lost. Now, the value of a digital twin is that all of that information can be brought together, not just into a single resource, but a single resource that has operational viability over time. So whatever we get from each of those departments, we can integrate it. You can turn on layers and off layers. So if you're only interested in the water infrastructure, you can see that if you want to add others. And of course, you know, it's not just the infrastructure sides. There's open space, tree canopy is a very important thing, and ultimately people. So the ability of a digital twin, not just to collect a wide variety of information, some of which ultimately comes in as qualitative information. The community tells you what it wants or it tells you what it likes, but it can grow over time. So typically for both the public sector and the private sector, they understand the value. The challenge is often, how are you going to make that happen? How are you going to implement that? It has a cost. We've worked with clients where sort of as a side part of the project, we've dabbled in this. But I don't think, it's great to hear about a city like Madrid. There are other cities, a lot of the European cities, I think, are at the vanguard of this, where they say, this is the future, we're going to make it happen. Not every city thinks that way. And unfortunately, a lot of the developers are very dollar-driven. And so they'll consider it, but it's one of the very first things that gets cut out. But I think people understand and recognize the value. It's just the case of, we just need to make it common practice. This is what we do.
Yeah. So considering that, you know, a lot of the lifelines of a city are subsurface, right? What kind of considerations are coming into play if you think about urban digital twins and subsurface utilities and all of these infrastructure that are hidden?
If you think about it, you said it, they're hidden out of sight, out of mind.
Yeah, exactly.
You know, we tend to think of a city as two-dimensional, pretty much streets and right-of-ways, and then three-dimensional, meaning buildings that go above. We often forget that there's a lot of stuff below, and the only time we think about it is when something goes wrong. You know, a water main breaks, and right away you don't see anything, but then suddenly the roadbed starts to sag, or water comes up out of the manhole, and then all the power cuts down because it turns out there's an electrical switch next to the water main, and you've seen it when they cut open the street and there's floods everywhere and the traffic is stuck, and then they open it up and there's all this stuff in there, and it's accreted over time. Done by different departments at different times, on those drawings that I mentioned that are on a shelf somewhere, and nobody knows where anything is. I have a colleague who's an expert in this sort of subsurface infrastructure. He's done some work with the Tandon Center at NYU. And in New York, he says, on any given day, there are 300 holes being drilled in the street somewhere while they figure things out. New York's only 300 square miles. It only has 6,000 miles of roadway. So it means that they're continually digging things up. It's very much, you know, you're exploring. Well, if we had systems where all of that was understood. We knew where this particular pipe was. We knew where that conduit went. Not only would it make dealing with repairs a lot easier, it would make preventive maintenance a lot easier. You'll say, wait a minute, that water main's 125 years old, has a 75-year life. We should probably go in and take a look at that. And while we're there, we can move that electrical conduit away from it so that if something does happen. But think about it, even New York, which is a fairly compact city, 300 square miles, that's a lot of infrastructure. So I think that, start small, begin to map those systems, begin to figure out where things are, and then layer additional, and then look for pain points. Because if you think about it, resilience isn't just storm surge and sea level rise. If your infrastructure blows up, you're not resilient. So.
But I just keep that thought, storms, winds, heavy rainfalls. We're talking a lot about climate change these days, and I have a tough question for you probably, but you're a consultant, you're used to that. In which ways can a digital twin help to design resilient cities when it is, less and lesser reliable on the experience we have in the past, right? If we look into the future, getting, more extreme and uncertain events. So how do you deal with that?
I have a colleague, a Hatch colleague, and he would argue that in the era of climate, twins are not a nice to have, they're mandatory. And you could argue that the very first thing you should do if you really want to enhance the resilience of your city is you should map everything. You should know where there are problems, potential. And you're absolutely right. There's a lot of people who think, well, 100-year flood means once every 100 years you'll have a flood. That's not the case. You could have a 100-year flood every year for 3 years in a row. That's a simple one. We can sort of measure how. I live on an island in Florida that is 2 meters above sea level. Last year, in October, almost exactly a year ago, it was ½ a meter underwater. Okay? I don't need a digital twin to figure that one out. Okay. But then, 10 days after the first, this was a hurricane, Hurricane Helene, we had Hurricane Milton. And it took down all the electrical infrastructure, which was all above ground. And so we went a week without power. And effectively, you can't live in that environment. And just the amount of damage that was done, the storm, the flooding, you have to learn how to address that. But the electrical, you go a week without power. Something like 6,000 households had to move, had to leave. Enormous inconvenience. And that's all things that can be mapped ahead of time. The great thing about digital twins is you can develop scenarios. And with the AI tools, you can develop a lot of scenarios pretty quickly, and then you can evaluate them, saying, well, if we're looking at this criteria, which ones are the best? If we're looking at that criteria, which ones are the best? And you can even put in things like, well, community acceptance. You do surveys, you talk to people, and you say, yeah, we know what people want. These 3 scenarios rise to the top under that situation. With those scenarios, you can begin to go into preventive maintenance. We all talk about adaptation and hardening and mitigation, et cetera. That's physical. You build up seawalls and the like. But there's also the sort of operational aspects of it. And if you know that something is prone to failure, that should be the first thing you think about before the failure happens.
Yeah, thanks, James. And you mentioned AI. I will come back to that in a minute. But let's listen to Andrius. And I was wondering, what are you currently working at KTU with regards to, let's say, resilient urban city development and campus design, also taking the operations into account?
Yeah, so thank you, Richard. Glad to be here. And not too many academics, I believe. So in the project that I would like to highlight in KTU, you can see on the screen, together with Bentley and other industrial partners, we work on the platform where we track main operational parameters of our campus. It's basically meant for calculating real-time CO2 footprint. So we track over 2,000 parameters on site: indoor environmental, energy production through renewables, energy consumption, electrical vehicle charging, and occupancy and things like that. And we use this model for various things, including teaching, education, hackathons, but mainly the main idea is to develop basically a model that can serve as a small city, and so cities can follow the same logic. So in our campus we have 15 buildings. Of course it can be considered as a small city. But it integrates two things that are important to us. One is this operational sustainability issue, and another one is energy resilience, which is also very critical for us. So recently we included in that model live data from the national grid. So we know at every hour how the energy is produced in Lithuania, and the way we consume it, it's recalculated into operational carbon footprint. Yeah, so that's more or less it for this project. Yeah.
I saw you there in the midst of your students,
yeah.
Right? Nice picture. I was thinking, you know, how are you preparing this next generation at the university, the next generation of engineers and architects in your case, to tackle these, you know, challenges that we have in urban infrastructure? You know, for example, are you preparing them in the curriculum for, you know, are you training digital twins, and are you integrating AI into your studies?
Yeah, academic programs are not easy to change. So even when you want to do it. So at the moment, yes, we do. We have lots and lots of initiatives, mainly, I would say, at the master's level. So once students already have some basic fundamental knowledge, they are skillful in their own disciplines, we can teach them these tools. We organize hackathons, PhD schools, different challenges for students, so mainly through that. In terms of courses, we do have courses on building data management, on facilities management, where these topics are also integrated. It takes time, but also speaking about AI and what has been discussed in the panel this morning, we see two sides of the coin. So we, personally, I think when we view these technologies like AI and co-pilots, we see them as professionals with 15 years of experience, and that's a really big help for us. But for students, when they don't have yet their core skills, they might get used to very quick answers, and you know, it can be an issue because professional instinct takes time to develop. So you need to do a lot of projects, calculations, and things like that. Yeah, but I mean, digital literacy, in my view, changed the way we perceive it. So every student should have a basic knowledge of machine learning, of AI. So this is something that we are integrating, but we are trying to do it in a way so that it supplements the program, not replaces the core fundamental things. Yeah. And
we are proudly supporting you in that mission.
Yeah, we work a lot with Bentley Education.
Now, let's have a look at China. We all know, you know, the scale of urbanization in China is really mega. It's creating mega cities, and year over year here at the YII in Infrastructure Going Digital Awards, we have impressive applications where the size and speed of that urbanization is really outstanding. So Lei, how would you describe China's current state of maturity with BIM and with digital twins today?
Okay, thank you, Richard, very much. I'm very pleased to be here as a panelist, and good afternoon, distinguished expert. As to the question, China has the digital transformation standard, a maturity standard. As far as I know, lots of Chinese enterprise has surpassed the initial stage. Our company now is advancing on the way of the leadership level. We developed BIM and the digital twin to build algorithm and models to support the business. And our BIM modeling with level of the development 400 and above nowadays. we are partner with Bentley for almost 20 years proudly. Bring dozens of Bentley software together, enable thousands of our engineers to working together in a large scale to collaborate it. Let us become more viewable, more efficient, and more smarter. We are very proud to be the first team in China to apply AI successfully on Bentley software, a true pioneer achievement. We work together with Bentley team to explore AI application in open plant PID. Our system can quickly identify valves, instrument, and the component in the existing PID drawing and convert them into a machine learning format. The design efficiency has boosted by more than 10 times. So the cloud platform developed a unique advantage. We combined the data of the EPC and the production stage and built the digital twin factory with thousands of high-frequency dynamic data and achieving the breakthrough in predict the production, the maintenance, and the quality of the production control. At the same time, to guiding the design of the next new generation equipment.
Wow, I mean, just to also a little bit introduce the company that you're representing here. Baowu Steel Group is the world's biggest steel producing company with approximately 130 million tons of crude steel. You are operating huge industrial facilities that are definitely comparable with small cities. So Lei, what kind of approaches do you, let's say, implement to make those factories sustainable and resilient?
Yes, Baowu Steel is not only big, but also located in metropolis, just at the mouth of the Yangtze River in Shanghai, the 26 kilometers away from the center of the Shanghai. The factory area is 21 square kilometers, and we have 13,000 employees. How to make it urban steel plant? Let's take a look at the radio. Over the years, we have continuously focused on ESG and promote green production and product, including the low carbon emission and efficient energy and clean energy and extreme energy efficient circular economy and intelligent manufacturing. The PM2.5 factory area is even better than the downtown of Shanghai, attracting small animals such as a peacock and a red deer habit in the factory area, and even sighting the endangered Yangtze River dolphin near the mouth of the Yangtze River near our factory area. And Baowu Steel Zhanjiang factory in Guangdong province has transferred 30 square kilometers of rainwater collection and treated into the industry water. The annual amount of the rainwater collected is about 12 million tons. The rainwater meets as much as 44% of the demand of the production water needs. Make it a sponge steel factory. Both Steel's flood control facility are built to withstand 100 years flood. The drainage system is connected to the Shanghai municipal pipeline network. The plant also built Bao Steel Reservoir with the total storage capacity of near 12 million cubic meters. It's not only one of the Shanghai living water resource, but also a key flood control facility. It worked together to prevent the flooding, especially when typhoon, the tide, and the storm, heavy rain hit simultaneously. Bao Steel also has its own power plant, offshore wind power and the solar power. It also has the emergency power generation capacity. The power plant is connected to Shanghai power grid. When heavy rain or other natural disaster strike, the plant arrange off-peak production or temporarily shut down. So the factory and the city work together to ensure the resilience.
Understood. Thank you very much. I'd just like to also say to you, we will have a Q&A session at the end of this. So if you want to bring up questions, you can already collect. And also to those joining us online today, you have the possibility to pose questions in your online form. We will bring them up later. Okay, back to you, Rebecca. You don't have that same situation as Lei, obviously, where everything, the full value creation is in your administration, right? It's almost quite the opposite, I would say. You have different districts, you have departments, each using different vendors, different applications and systems. What challenge do you see with the integration of all of this?
Well, as you said, this is a real challenge for us or for large cities like Madrid. If you think about it, we serve more than 3.5 million people, and our administration manages a huge ecosystem of different sectors, departments, districts, and services. All of them using, as you said, different platforms from different vendors. This has led us to go for a fragmented and really costly systems with really high maintenance and really poor data quality. Actually, we are not used to share this information, this data, because there's no interoperability in between. So, however, our digital office is working already in a single global management platform. And what about the challenges of this new platform? For sure is the interoperability and the integration and the standardization of all of this data, so I can understand, use the data from another department. But also I will add another one, that is changing the way that public administration works right now, going for a more flexible and collaborative approach using use-based digital platforms. I think is really important.
So that's quite a different situation to do, Lei, if I may say, right? You have 4,000 engineers and architects reporting to you. So you like to comment?
Yes. We also face the challenges such as the information silo, data delivery and the data granularity, and integrated modeling software choosing, and the standardization, and the lack of the talent. An important matter, I think, it is the standard creative. In order to connect the data, we innovated a new fine-grained a plant breakdown structure, yes, to link the silo data across the whole EPC and the production process throughout the factory life cycle. We are now working not only working in a traditional boundary, just in the engineering field, but extend to the production in the digital twin. Because we can, with this standard, we can integrate it, the real-time data and form the digital twin.
Sounds good.
I saw, James, you were nodding when we spoke about connectivity in cities and interoperability. So what are your thoughts?
I'm going to give you a story.
Yeah, please.
In 2011, I worked on a project of a city in the Gulf, on the Gulf of Mexico. A small city, 300,000 people, 2011. And as we started the project, we said we need to get all of the department heads together to meet with us at one time. And so we had a meeting, and about 12 or 13 people came. And right before we started, one of the people looked around and he said, "This is great. We haven't all been together since Katrina," which was 6 years earlier. Okay? So the people who are in charge of running this incredibly complex entity called the city never get together.
Yeah.
They don't talk to each other. They were in actually different buildings dispersed around the city. Exactly what Rebecca said. They don't share data. They don't. Now, that's 15 years ago almost. I think a lot has changed over time. I think there's an awareness now that the tools are available. Data is very, very important. It has to be shared. I mean, one of the challenges that we see, we do mostly upfront planning, strategy, that sort of stuff. So we use one set of sort of tools and equipment. Then we hand it off to architects and engineers, and they use different tools. And then they give it to contractors who use, and then ultimately it goes to facilities managers and operators, and none of that data is relevant to them. So even if you say, well, everyone has access to the same data, the actual tools that you use, the platforms, the software, has to integrate. And it's really time consuming. It's the kind of thing that maybe an academic institution could sort of take on as a challenge, a test case. Because, you know, think about it, I'm talking a city of 300,000. What about a city like Tokyo, which is, what, 37 million? I mean, it's just mind-boggling how complex these are. But we know the tools exist. And so we're clawing bit by bit to sort of pull it all together and make it happen, all the while dealing with resilience issues and storms and sea level rise and fires and droughts and all of that. I mean, cities are just these ferociously complex entities. And in order to really operate them effectively, we need the right tools. And those tools are starting to exist. So it's an incredibly interesting time. But the point that Rebecca made about integration and interoperations is essential.
Yeah, but also, if we talk about necessities here for interoperability, the data has to also be accessible.
Yes.
Right? So I think that's what we're also working on with our users. So I'd like to ask my colleague Subran, who's here sitting in the front row, who's working with many cities, by the way, on this front. What is your experience? What is our experience actually from this engagement when it comes to data accessibility, Subran?
Thanks, Richard. Oh, it's a bit loud. So yeah, as you mentioned, I work in various projects, one of the first things we do is try to make data accessible to them, and that's the idea of doing that very quickly, fast, time to value, and we do that. We do that either with open data, the data they have accessible, but here is a common thread between all the various projects that I've led with. Once we bring a couple of data and open data sets and share that, two things happen. Number one, another department says, ooh, I don't know we had the data, because the data is in the cloud now. That's like the first thing. And the second thing that happens, immediately after that, they say, can I share my data on there as well? So what that leads to is a sense of collaboration. It just becomes organic because they say, I would like to contribute to that data set. So these things are accessible. Yes, there are standards to be considered and so forth, but just data availability, to your point, James, awareness is the first step, and then cleaning it up, standardization sort of follows there. I mean, we have a special guest today, Anne from Den Haag here. Anne, what steps are you taking to making data accessible?
Hi everyone, Anne from The Hague. I head up 2 teams. Both of the teams are responsible for the assets, as in the properties of the municipality of The Hague, and my teams make sure the IT around it keeps working. So sensors, cameras, bridges, tunnels, lights, sewages, so also underneath. Mm-hmm. And what we do is we have our standards, but we also put like BIM models into our digital twin. And we reuse that data to feed our maintenance products, and also to plan that ahead. What we also do is we look at, okay, how can we prevent noise pollution? When you have a concert in the open air, you don't want everybody around that place to not sleep that night. You just don't want that. But we also use it to predict crowds. The Hague is at the sea, so when the sun hits, everybody wants to come to the sea, and just things get clouded, and get a lot of people at the same pace, at the same time. And you want to prevent that, because you want everybody to find a parking space, you want everybody to have a seat in a tram or whatever, and you don't want everybody in one little place on the sea when you've got all the beach. So you want people to distribute. That's another way that we reuse it, but we also use it to predict, as in heat damage or floods. And that's a really good way to reuse the information. What we also have in the Netherlands is standards, like you were saying. Information has to, or data has to answer to certain standards, so that we can reuse it in every different system or in every different piece of software.
Thank you, Anne. In the keynote today, do you want to?
I wanted to ask a question. Does the public have access to these data?
Yes, they do.
Because I think that's essential, because most people don't understand how a city works at all.
No, they don't.
At all.
No, we reuse it to help with planning. Yeah. So to take the public along and tell them, okay, we're gonna replan this little bit of the city for you, and these are the different options that you have. Right. And we also use it to help the public find parking spaces in whatever they need. Yeah. Yeah. That's perfect. That's great. We're not there yet, but we're getting there. Yeah.
Because it always never amazes me at how little people understand about their cities.
That's actually, some people can't find it, so they call. Right. Or they send an email and then they get all the information that they need. But making it
self-serve.
Yeah, exactly. Making it easy is the first thing, but actually helping people to find it is the second thing. Right. And that is, that's sometimes tricky.
Yeah, good question. Belongs to data and information accessibility for all, right? Yeah, definitely. So this morning in the keynotes, we heard a lot about artificial intelligence. And I'm wondering, at Hatch, one of these global big engineering companies, are you using, and I think yes, but what way are you using AI today to really increase productivity, specifically in your business case there?
Yeah, I mean, it's a little bit, I think it builds on what Lei was saying before. We design a lot of facilities. We do a lot of work in the metals space. We do a lot of work in power and energy. So we're talking about smelters and furnaces and power plants. Yeah. And I think we're constantly exploring. There was a little bit of concern initially about AI, about data privacy, data accessibility, et cetera. I think those have been addressed. I mean, part of it is you like to build a very complicated facility ahead of time, so you can figure out how to build it. Are there going to be any particular issues? Construction safety is a big issue, so you always look for situations where there might be potential for something to happen negative. So you're using it to predict and develop tools like that. You say that after the design, it has to be handed over to the contractors. How is that interface going to take place? So it gets back to, I think what I said earlier, it allows you to create lots and lots of scenarios. Excuse me. We heard, you know, what do you say, 8 hours of work is now done in 10 seconds, I think, on the video. It used to be that it was laborious to create 2 or 3 scenarios. If you can now put in permutations and say, okay, there's now 300 scenarios, very quickly we say, here are the top 10, and then you can query them. And you can say, as I was saying earlier, well, this one has the best financial return on investment, but has a bigger environmental impact. Or this one is pretty good in terms of resilience, but the public's not going to be so happy. So, just it's having more options and having ways to evaluate those options in a somewhat objective way. It's just incredibly powerful. And, I mean, you know, they mentioned Project WISE this morning. I mean, that's a, you know, you think, well, that's pretty straightforward, but it allows us to work with global teams across different offices effectively. You know, you saw the example this morning where the 2 engineers were making changes at the same time. That didn't exist 5 years ago. Yeah, right. I mean, in order to mark up, somebody had to mark it up, then somebody else had to mark it up. So there's the efficiency of our work process, which is, you know, taking advantage of these tools. Then there's the efficiency of the actual design, so it's better. And then ultimately, if you want to reduce your carbon footprint, you want to lower energy, et cetera, you have to measure things. Because otherwise it's just, well, we think we're doing better. So these tools, I mean, I think the challenge is the tools are developing at one pace and you're needing them at another pace. And for a while, we tried to actually create our own tools, we meaning my group. Yeah. We're not very good at that. Oh. So, you know, it's a learning process. Yeah. But it's where we can partner better. Well, of course. But I don't know. So, it wasn't arrogance on our part. It was stupidity. Well, we just said, this is cool, and we went down a rabbit hole. But you make the right conclusion there. Before I open up to the audience here with a question, I have one more to Andreas, because when I have a professor up here, I also think we have to look a little bit more into the future. You're doing research and you are part of international research networks, right? So looking a little bit ahead, what do you see, what do you observe as the next big thing in urban infrastructure? Specifically, we look into, you know, urban resilience. What is coming there?
Yeah, I think it's a really interesting question in this rapidly changing world, and I think we can only look just a few years ahead. But I don't see any kind of single technology like changing the landscape a lot. I would say that it probably will be a blend or a convergence of different things, and I think this morning we saw some really interesting examples of that. So if we look across research papers or patents or funding calls, digital twins are all over. I think when Bentley started talking about digital twins, there were 0 calls in European Union for digital twins. Now we have a lot. So technologies that enable digital twins, I would call them, you know, those that will be still developed. So sensor networks, narrow AIs for specific applications, of course, as James said, with the simulations and analysis of different scenarios. So yeah, and if you add on top of that data-driven design, then it becomes really interesting. And maybe, you know, my view would be that if we created a cell phone, now we want to make it maybe smaller and more comfortable. So we had few research projects where we engaged with industry and we talked about digital twins and adoption. And they said that still it requires a lot of effort. The costs of creating digital twins are still too high. So I would say that we should go for a lighter version of a phone in this case. So it should be more affordable, more accessible. Yep. That would also help universities to use that, teach new professionals, and maybe not only, you know, wealthy countries can use this technology. So I think we will see lots of development in terms of how these things integrate and how they become more accessible and affordable.
Okay, and you speak a lot about implementation here as well, right? I think also let's say the habit of those who develop and implement digital twins has changed a lot. We can get quite far with preloading digital twins that are there with open data without paying anything, right? So I think we're getting away from that perfect, all-encompassing digital twin, more to start quick, use an MVP, you know, take what you have, pull together, right? Yeah. And then go the next steps. As you said, James, you know, start smaller. Yep. That's also what I see going on in cities. Yeah. So let me have a look here if there are questions in the audience to our guest here. And I think you were number one.
Hello, thank you so much, Richard, for a wonderful moderation, and thank you all the panelists for sharing the interventions. I'm Anupma Madhuksood, the director of Water Digest, and water is my specific area. So my question is with Ms. Rebecca and also with Mr. James. So Ms. Rebecca, when we talk about urban water management and specifically with regards to leakages and losses in the entire conveyance system, I think Madrid leads. And in fact, you are a case study wherein the leakages and losses are less than 10%. Going back to India, we have a lot of leakages and losses in the system, and I think our efficiency is not more than 30 to 50%. So, how is digitization is also there in urban water management in the overall system of this particular distribution chain in Madrid? If yes, I would be happy to know the case study from you. And with Mr. James, my question is not related to AI or anything, but it is, you mentioned about integrated water management among various departments. And it's not the scenario in one country. I think globally, you also spoke about, all the respective departments are working in silos. So there is a need to collaborate. There is a need to have, integrated approach for dealing with the respective issues. So what is your take in terms of the policy interventions which can be brought into the system and breaking these silos and bringing the departments together? So thank you so much.
You want to go first?
Okay.
Yeah.
So I'm not a water expert, but I'm sure that some colleagues are working on a project like that, because now that we are going to have our digital twin, it's going to be easier to have this approach to another projects like water. But yeah, I'm sure in the following years we will have a project like that. I would like to know more about India projects as well, so I ask you later.
Please come to our water panel just after this one. Okay, James.
It's interesting. Different cities have different political structures, and different countries have different mandates and regulations. And I suspect in Europe, a lot of these issues it's mandatory. You will do it this way. In the US, it's a little bit more laissez-faire. In some cities, it's just no one is in charge. Each division does its own thing. I'm hopeful that, as suggested, if you say, well, hey, we have a central repository for data, can you contribute? Then people will all be pulling their information from the same place. If you have a very strong mayor, we saw Portland. Portland is very famous for basically making the head of sustainability reported directly to the mayor. And the mayor said, that is an important issue to me. It's a strong mayor. They were able to get a lot done. So part of it is just simply the corporate structure of the city, whether it gets things done or not. Part of it is, if you build a tool and you say to everybody, you all have access to this, and this is how we're going to operate going forward, I think, as was said, eventually people will start to collaborate. But a lot of it is the political structure of the city often mitigates against what you're trying to achieve, which is sad if you think about it, but it's a reality. Yeah.
Okay, there's another question.
Yeah, hi, great panel. Honestly, it's been really informative, and kudos to everybody who's speaking in a second language. It's so impressive. As an audience member, I'm jealous. My question is about, and it's also for you, Mr. Wessner, as well. Earlier in the morning session, I was sort of wondering whether your carbon capture tool, as part of the Bentley piece, whether that also captures the energy, the carbon footprint itself from the AI, all the LLMs, and how that's contributing kind of negatively to these. And I'm just curious as to whether the cities and other folks here are trying to figure out how to offset how that works against sustainability initiatives.
I think that was part of Madrid, right? Looking into operational carbon as well.
Yeah, actually, we had a really big problem with the pollution in the city, but for 2 years in a row, we are okay with that. So we have managed to don't involve some certain type of cars into the city. 5 years ago, it was just the city town hall, so a little part of the city, but now it's almost the whole city, and the air pollution is getting down and down and down. So yeah, I think it's a really good strategy that is working in reality.
Yeah, and the second part to the question is yes. I mean, it's part of our Bentley Infrastructure Cloud, right? We have first focused on the embodied carbon because that is impacting your design options, right? While designing, you can see the best option. You know, if you change material, because, you know, with a digital twin, you have the bill of quantity, right? And while you're doing this, it gives the engineers the power to change rapidly from option 1 to 2 to 3 to 1,000, right? You just calculate the best option. So that is the embodied carbon. And then we, of course, moving forward, also with the help of partners, other software vendors, but also universities are working on the operational carbon, right? How that impacts, because we know how much is deployed in a city or in a facility. And that helps us, of course, to look into the future as well. And then bringing that into dashboards, into our infrastructure cloud portals, right? So I think there was here over the year. Thank you.
Yeah, hi. Sorry. Scott Blair with the ENR. Thanks for the great panel, very insightful. I've done a lot of reporting on the LA fire recovery, which I think makes an interesting case study for resilience. Their goals after the cleanup was to build back all of the infrastructure, both subsurface and above surface were damaged, quickly, efficiently, sustainably, and equitably. But to do that, you're not just talking about the LA County and the public entities, because we have, you know, in the US, we have private utilities. Mm-hmm. So you're talking about getting the private and public sectors to cooperate, to all go in and not tear the road up 15 times to do every single, but I guess the component, and that's the component I'm most interested in asking about, is what can we do as a construction and design industry to set them up for success ahead of time before the disaster strikes, especially on the construction side. Like, you know, the scanning and planning, you know, like getting all the data together is one thing, but then having a plan to execute recovery is a whole nother one. It probably goes to you, James.
I mean, I'm a little bit familiar with the fires. I also remember that the Paradise Fire afterwards, the utility was basically ordered to bury all of the lines that had been elevated and had, in fact, contributed, I believe, to the fire. You know, it's interesting. Human nature says that after a disaster, you want to bring back what you had. So, I mean, they did that in London in the 17th century. They basically just built it back. We've done that after the Second World War. We're doing it, you know, we have hurricane damage, and then 2 years later, the homes are back on the, you know, on the islands. Maybe they're a little stronger, maybe they're a little better. So I think there's an inherent, just part of our psyche is I want what I had. So I want to bring it back. I do believe that we are imposing standards that say things have to be built to a higher standard. We have to use different types of equipment. We have to use different materials. But it's I mean, it's a challenge because we know this is going to happen more and more into the future. I mean, as I'm sure you're aware in California, certainly in Florida, it's getting harder and harder to insure things. And a lot of the value of property in the United States is propped up by the fact that you can get insurance. And if the insurers pull out, the game changes. And then maybe the impetus to do things that are a little riskier. You know, if you design your home 20 miles outside of the city in a wooded area, there's a chance it could burn down. If you design on a island, barrier island, there's a chance it's going to get destroyed. And so it's not simply, I think, a technological issue or a regulatory issue. It's really, it's embedded in, certainly in the US, the way we structure our economy and our society. And those are tough. I mean, that's no individual contractor or consultant is going to take that challenge on. But maybe that's the sort of thing that we have to start to talk about.
But since we are at a technology conference.
Yes, yes.
You know,
Look, I mean, I would say if you said to me, where do you think we could be in 10 years? Ever since the 90s, early 90s, I was fascinated by SimCity, okay? And you realize it's algorithms made up by a software developer. But we are getting closer and closer to really understanding how cities work. So at what point can we play SimCity for real?
Yeah.
Okay, and maybe it starts at a university campus. It's small.
We do some evacuation planning.
See, we're getting there. We're getting there. And then it gets to my question about bringing the public in, because imagine that you just had a dashboard that just told you everything you needed to know about the place you lived. And then there would be a case where digital, instead of tearing us apart, would actually, I think, be helping us coalesce. So I think, you know, we're in that very interesting, you know, period where everything's in transition and things are changing and some things will fall out and some things will happen. But I think standard of practice in 15 years is going to be very different than it is
and I think
today.
we have way long behind us reached the level that we have, you know, went beyond the game. It's really more reality. Many cities are using that. Many facilities, many corporates are using that in real estate right today to improve their efficiency and their effectivity.
Yep.
I could go on for another hour with you guys here. It's really a pleasure to talk to you and to the audience here. Thank you very much for your questions, but I have to close this now, unfortunately. Please stay with us. There's another very interesting panel just in the same room. Thank you very much, my four guests here, for your insights. I think we were able to highlight together what crucial role technology plays in the transformation of connected cities, you know, shaping the future of urban infrastructure. Ladies and gentlemen, if you want to have more information, just scan this QR code and it brings you straight to our press kit. Thank you very much for staying with us today, and thank you once again to our panelists. A big applause.